Chapter 4, Section 1, Solving Systems of Equations by Graphing. So first we're going to talk about what is a system of equations. So a system of equations is a group of two or more equations. The solution to a system of equations is an ordered pair of the form x comma y, and what's important is that that ordered pair works or satisfies each equation in the system. If we are given an ordered pair, we can check that it is a solution by substituting it into the original equations to see if it's true. We're going to talk about several different methods for solving systems as a part of Chapter 4. The first method is by graphing. To solve by graphing, you're going to graph each equation and then find the point where the lines cross. Now I'm going to say that the solution is the point or points at which the lines intersect, because we'll talk in just a little bit about what happens if the lines intersect each other in more than one point. We're going to have three possible outcomes. The first one is that you have one solution, meaning the graphs intersect at a single point. On the coordinate plane, so this is my xy axis. It's going to look something like this. You would graph one line, and then you'd graph another line, and you would find the point at which they cross each other, and that is the solution. This is also called a consistent system with independent equations. We could have also no solution. To have no solution, that means that the lines do not intersect, which is called parallel. On a graph, it'll look something like this. You graph one line, you'd graph the other line, and you would see that they're parallel lines. This system is also called an inconsistent system. And the solution is the empty set. The empty set is notated either as set braces that are empty, or that symbol meaning it's the empty set. Our final possible outcome is infinite solutions. Infinite solutions means the two lines overlap. Another name for the two lines when they overlap is called coincident, because the lines coincide. When you graph, it's going to look something like this. So you graph one line, and then when you graph the other line, it ends up just right over the top of the first line that you drew. So they're in the exact same spot. This is also called a consistent system with dependent equations. The notation is a little bit different. You're going to write it, it's going to be a set of all ordered pairs x, y, such that, and then you would list one of the equations. So this is just telling us that any x-y combination that works in the equation, and yes, you'll have two equations, you just pick one of them, because what this means is that they're both the same equation. So you just pick one of them and write it there. So let's first start out by determining if the given ordered pair is a solution. As I mentioned earlier, what that means is that the ordered pair must work when substituted into both equations. So I have my x value and my y value, and I'm going to substitute into the equation to see if the top equation is going to equal 11, which it does. So now I move on to the next equation and I substitute the x and the y. Which is also true. Therefore, the ordered pair negative 1, 5 is a solution to the system. And we're going to take a break in the video so it doesn't get too long and pick up with some examples of graphing in part 2.